Hello, everyone. I hope you're doing well. Welcome to today's class, Lean Six Sigma class on supply chain, digitalization, and technology. Now, we're living in the midst of a technology revolution. We are actually living at a very interesting time in the world, if you look at the world history. And one of the biggest things that have happened in the past, let's say 100 years or so, um, I would say there are two main milestones that the world has seen. The first one is globalization. And in my global supply chain management class, I speak at length about globalization and the impact that it's had throughout the world. The idea where import and exports and the tariffs have gone down and import and exports have subsequently increased has really revolutionized the world. Transportation costs have gone down, but another really big milestone that I think it's important to talk about is, the internet and how the internet got introduced to the world. And today we have, in addition to a physical presence, we now have a virtual presence. And initially there was a learning curve. There were a lot of naysayers, and there were some that didn't really embrace technology. But over a period of the last 20 years or so, uh, the internet has become an integral part of pretty much all companies and all operations. And not only that, but it has triggered, and it's a lot of changes in the way business is done. It's been a game changer. So that being said, I'd like to talk a little bit about the internet, its genesis, and the impact that it's had, because I think that's a very good start for us to really, before we start talking about its impact and supply chain technology, let's start at the beginning of the story. All right, so as I just mentioned, a couple minutes ago, we are right now in the midst of an industrial revolution. It is the fourth industrial revolution in the world. So if you look at history of the world, there have been certain game-changing milestones. The introduction, for example, of water wheels, steam engines, um, electrical engineering, automobiles, all of these were, led to certain industrial revolutions. Um, net, what an industrial revolution is, it basically revolutionizes or changes the way the world has been working up to that point. And so, we are in the fourth industrial revolution of the world, and it's changed pretty much the way all businesses everywhere across the world operate. And so another terminology for the fourth industrial revolution is also um, called the information revolution. So that's another term that's used for this particular industrial revolution that we are currently going through, and how it's worked. So let's talk about this revolution. And let's just have a look at how, what are the steps that have happened um, for us to reach where we have today. Well, the first step was digitalization. And so, this is, the cover of this presentation of mine is a pretty interesting graphic here, right? And you sort of see human beings, right? And there's this Stone Ages, we're starting right at the beginning of the world. And then slowly and steadily, humans are, evolving, um, hopefully becoming smarter. I don't know if they're becoming better overall, but definitely improving in several aspects. But here, what you see in this image is that it seems like they're transitioning into becoming or merging with technology. And so basically this particular image is symbolizing digitalization. And what this basically means is it talks about there's this conversion that happened. And so this happened, this particular step, the digitalization. So if you look back, the 1980s is when the internet really came, with a bang in the world. And in the 90s, there was this whole process of digitalization that kicked off. And this basically meant that all information in the world was being translated into a digital form. So whether it was songs where, previously people were hearing songs on tapes, or, watching movies through videotapes, well, all of that is being translated to digital form. Voices were being translated to digital form. Um, Products, every product started getting labeled with, could be a barcode, could be some sort of number. Human beings started getting, in the US, a social security number, in places like Pakistan, an NIC number. And with that, that was a number that was in effect their specific number. And in the digital world, that is what they're known by. So this entire digitalization conversion of images, sound, objects into discrete numbers, this was took a long while. And there was there were certain, year 2000 was basically but there was almost like this hard stop where by the year 2000 there was a big push to get everybody, almost everything, all sounds, all images, all objects digitalized. And this happened. There was this push actually worked, and it happened. The next step after that, in the early 2000s, there has been a step of, digitalization of processes. And so the process of how things were working, technology was working, changed. And so new things emerged, such as big data, Internet of Things, machine to machine communication. And we will be talking about all of this. But net, you know, there was technology, a big boom in technology being merged with the internet. And so this was the phase where technology started merging in with the internet. And the final stage was digital transformation. And this is the stage where basically everything in the world, all of society, started really absorbing this digitalization and merging it with their day-to-day lives. And so this has been a pretty steep learning curve. And if you look at it, the world has changed significantly over since, let's say, the 1980s till date. And we have been, and this revolution has happened in this process. So let's step yet one step further back, and let's look at, what is the internet? What is it really like? I mean, if you had to think of an image of the internet, what would it be? And honestly, it's very difficult because it's invisible, right? I mean, we use it on a day-to-day basis, but we never really think of an image of the internet. Well, I did a little bit of research, and this picture over here is, what the web looks like. It's literally like a web. And here in the bottom, there's another image over here, and let me try and enlarge it a little bit for you. And what you see is, and they're all it's there's a it's basically numbers, right? So things within this web, it's numeric based. There are usually a lot of binary codes, and binary codes means one and zero is used quite often. And so that's what the internet looks like. But okay, let's see the genesis of the internet. So the internet was originated by the United States government. And in the 1960s, they started building a computer network, which was known as ARPANET. And so they started building this. It was a secret. It was, they were trying to figure things out, build it. And they realized that, look, this is going to work. It's actually working, it's functioning. And then they decided to share it with the world. And in 19 on a really large scale, the internet was introduced in I would say in a big scale in 1995. So that's the point where the internet, so it was launched earlier, like I said, in the 1980s or so. There was, we all have heard of the internet bubble. So it was around there, because 1960s it was developed, but it came in a big way in around 1995. Now, let's look at the number of internet users. In 1990, there were, 0.25% of the world population, just 0.25% of the world population was using the internet, which amounts to about 12.5 million users. This then increased to 1.2 billion in 2002, and that's 19% of the world population. In 2010, 1.8 billion, or 26.6% of the world, got on the internet, started using it. By 2016, close to 50% of the world, or 3.6 billion people, were on the internet. Today, I would say that this is a much larger number. And in fact, it's interesting because today it almost seems that if the internet for some reason shut down in the world, we would find it very difficult to function. Right, recently, there's the coronavirus that we're dealing with, and there's a lot of, people are also worried about, oh my goodness, what if the internet slows down? How are we going to work? What's going to happen? So the internet has, facilitated us being able to watch movies, hear music, just work, be connected across the globe with our friends, our family. So it's become a huge and integral part of our lives. But it's also really important to remember that this is a pretty recent um, revolution that has happened, and it hasn't been all that long. So now here's the other thing: with all of this information in circulation, the question is, how is this information stored? Where is it stored? And is there enough capacity? So a lot of you already know that there are internet servers, which are very large machines that have the capability of saving a lot of this information. There's also a terminology by the name of cloud, and these are also huge, huge, huge main, servers. And it's almost like these farms, huge farms full of servers, where they have the huge capacity to save all the information. And so there is, a lot of capacity right now to save information. And if you want to understand how much, it's basically 4 times as many grains of sand on Earth. So it is like a humongous amount of capacity that we currently have to save information. And so, and of course, the reason is that this information has, increased so much is that the internet facilitates exchange of information, right? It makes it easier for you. I can upload a video right now and you can watch it within minutes. So it's facilitating communication, and in order for you to be able to watch that movie, that movie has to, the internet can definitely share it, but that video has to be stored somewhere. So it is going to be stored in in some server somewhere in the world, and then through that server, the internet will then send you that information back to you so that you can view the video. Now, all of this is great, and it's it's been so-called so far. If you ask the world, and this is something that many times I've asked the world, my class, what do you think? Net has it been good or bad? We all know that there are certain negative aspects of the internet. There's an information overload. There's this whole idea of hacking. There's so many negative aspects of the internet as well. But net, if you ask the world, has it been a good thing to have this internet? And you'll hear predominantly the answer being yes. And again, just imagine previously making a phone call, a long distance phone call was extremely, extremely expensive. If you look back, maybe 50, 60 years back, communication used to be done via mail, and it used to be very difficult to send something, and it used to take ages for it to reach, the mail to reach its destination. And so then there were different things that came, telegraphs came and all of that, but still it was just very difficult, very expensive, very time consuming to communicate. So today you can pretty much communicate with anybody anywhere in the world for free, which is something unbelievable. You can send emails, you can send photographs instantaneously. And again, this is something that has truly revolutionized the world. So that being said, now I've kind of given you a flavor of the internet, the information revolution we're going through, and we've discussed globalization, and again, even with globalization, net everybody says it's great, right? We people are today, one most young people love to travel. This is something that they like to spend a lot of their money on. They're able to travel all around the world, unheard of 50, 60 years ago, unheard of. Again, all of these things are happening. But even with globalization, it's important to remember that today the coronavirus has spread like crazy all over the world. Maybe it could have been contained if we were not living in the world of globalization. So with all of these, amazing things, there are certain negative things that the world is also having to understand and deal with, and trying to learn, because this is all new stuff. um, Globalization happened in, again, around the 2000s, and around that time is when the internet came in. So both of these things have happened, and around the same time period, and it's been great, but it is really changing the way the world works, and we're all trying to learn how to enjoy the good but also deal with the bad. So now let's talk a little bit about how all of this, how the internet, we've been discussing how globalization and its impact on supply chain management, but let's also discuss, some technology changes that have happened through the internet and through globalization. So let's look at the recent challenges in supply chain management. So now, because of globalization, here in this slide, you can see how complex global, supply chains have become. It's usually in the past, again, if you turn back time, 50 years ago, 60 years ago, 70, 80 years ago, well, at that time, it was all local manufacturing, and things were made pretty much within specific locations, and it was that's how it is. So the supply chains were also more simple. Nowadays, they've just become a lot more complex. Now, if you are part of this supply chain, at any point in the supply chain, you will want the ability to track and trace goods that are moving along the supply chain. And would also, perhaps, if one of your goods is, let's say, moving along the supply chain, you would want to know what the status is. Where is it? Where is my good right now? You definitely would not want to be in the dark and just sitting and hoping that it's going to reach its destination. In fact, you would want to continuously be checking on whether or not it's reached its destination. And maybe, if on the other hand you're a consumer in this supply chain and you're awaiting for something, you may want to be able to trace exactly where it is, If for example, there's some sort of contamination in something that you delivered, you may want to track what happened, where did it get contaminated. So there are a lot of things where there are a lot of reasons now why supply chain visibility is becoming a very, very important concept and challenge for companies, being able to really understand what's happening end to end in the supply chain. And again, the fact that there's so many parties involved in every shipment is making it even more important to have visibility. Then there's also certain other reasons why visibility is becoming more and more important, and that is the amount of different conveyance changes that happen. So maybe your product is on a ship, and then it goes on a train, and it goes on a truck, and because there's so many changes, you may be even more nervous to know where it is, has it reached its destination. Sometimes there's consolidation and deconsolidation, and I talk a little bit about this in some of my other classes. But it may be being put in different uh, containers, it may be being shipped in different forms, and so all of this leads to you know more of a need for visibility. Okay, so there are basically in supply chain management, there are three different types of technologies that have emerged in the recent past as a result of these new challenges in the world, as a result of globalization, as a result of an increase in supply chains complexities. And the three different types of technologies that have emerged is, the first one is data capture and translation technologies. The second one is data transmission and upload technologies. And the third one is data access and actionability. And I will be taking you through and making you understand all three of the new types of technologies that have emerged as a result of all of these recent changes that we have seen in the world that I've spoken about, including the internet and globalization. All right, but before I do that, let me talk about an important concept in supply chain management, which is track versus trace. So there are going to be goods in a supply chain. In certain cases, manufacturers may or consumers may want to be able to trace products, and in other situations, track products. So let's understand the difference between track versus trace. Tracing products. Tracing products basically means understanding where the product came from. Where has it been? Where are all the similar ones? Generally, what we're talking about is understanding the source of an object. And this is important because let's say there's a mistake that has been made in a pharmacy, there's some medication that is, somebody's gotten sick because of that medication. There is an illness that has been caused because of a medication. In that particular case, you will want to be able to trace where that medicine came from. And you will want that particular factory recalls its products not only from your pharmacy, but from all pharmacies. And so recall becomes very, very important. In order for this to be able to happen, in order for you to be able to trace products, it's important that a very clear record of all past activities, locations, and events is maintained. For example, if you have a pharmacy and you have this medicine that's, maybe you looked at the box, it's expired, or if there's some problem and people are getting sick because of it, well, the only way you will be able to trace its back to its origin is if you've been keeping track of who delivered those goods to you, which company those that medicine came from, and which location that medicine came from. And only if you have all of that information will you be able to go back and say, hello, this is a problem that we is happened. Can you kindly recall your products as soon as possible? So that is one particular phenomena, the whole tracing aspect, that is very important in supply chains. And it's over a period of time, it's gaining importance. The second important phenomena is tracking products. Tracking products basically means being able to identify where your product is right now, and being able to also identify an approximation of by when it will be able to reach its ultimate destination. Now, this basically is a very empowering thing, because you are able to track your product, the route of the product as it goes downstream throughout the supply chain from the beginning to the end. And you can get real time or near real time information on where your product is at a particular point, right? And if, for example, you're let's say you have a GPS system and you find out that your product is midway somewhere and there's going to be a huge traffic jam, there's an accident. Well, if you're able to track it, sorry, you can change the route and you can tell the driver, hello, you have XYZ goods in your truck right now, please can you change your route? So you can actually make some tactical changes if you have near real-time tracking information. So this will, once you have this real time information, it will give you an ability to make future looking analysis. So if you think about this, and if you look at this uh, picture on the slide, what you'll see is two arrows, right? Tracing means you're going to be going back, looking backwards. You're trying to trace the origin of goods. Tracking, on the other hand, is something is en route to its destination and you're trying to track where it is on that route. So this is two these are different things, but these have become requirements in supply chain management. So all this, excuse me, all the technology that I'll be introducing to you in this lecture, the idea is to enable companies to trace and track their goods. That's the reason that these technologies have emerged, because there is this need in supply chains. And this need has come, as I mentioned a little while earlier, because supply chains have become so much more complex because of globalization, because of the internet, and an increase in the speed of communication. So all of those changes have happened. As a result, these are new needs that have emerged, and there have been technology that has been developed in order for companies to be able to do tracking and tracing of goods. All right, now I'm going to go and talk to you a little bit more in depth about tracking. Now, as far as tracking goes, generally speaking, if somebody was, in the past, it was done. It was done in a different way. Today, if you look at tracking, this is the kind of milestone reporting UPS has. It's this is where it is. This has happened. You have detailed reporting that's being done. In the past, reporting was also being done. Let's say you had to travel from one location to another. Well, in that case, usually if you were traveling and you were, let's say, going by train, maybe while you were in the middle of your train, journey, you stopped off at a certain stopover and you made a phone call to your family and said, look, I'm currently in the middle, I've reached the middle, and all is well with me, and I'll be reaching the final destination in, let's say, X period of time. So in excuse me, in tracking, there is an event or milestone reporting that is done. And so whenever a key milestone or an event happens, then at that particular time, a message is sent. It is documented that this event has happened or this milestone has happened. And this is widely used in freight transportation. So here's an example of freight transportation. What does freight transportation means? It means the transportation of goods, right? So you're transporting goods along the supply chain. And when you're transporting goods, then at every single one of these points, you want that there is some sort of a message or some generated, and somewhere this is documented that this particular milestone has been achieved. And as you can see, there are quite a few different milestones because, again, supply chains are becoming more and more complex. This is another example of a milestone reporting, and this is a report that has come from UPS. And so they have basically over here explained, they've given the location, they've given the date, the time, and the activity that happened. If we look at the history of, tracing, there is, for example, this this champagne, for example, right? Well, champagne originally was made in in specific place in France called Champagne. Anything other than any other wine that was made in a place other than Champagne, France, was not considered champagne. So if you wanted to figure out whether or not a wine is actually champagne, you would have to have the ability to trace back where its source of origination was. Let's look at a definition of what tracing is. On this slide, it says, it is the ability to capture a product batch and its history through the whole or part of a production chain, from the harvest through transport, storage, processing, distribution, and sales. So you're basically being able to, again, capture a product batch and its history through the whole or part of a production chain, from the harvest, transport, storage, processing, distribution, and sales, the entire process. And generally speaking, this is very good to be able to, for example, on the side, it talks about having defective airbags and being able to trace which plant it came from. So those are the benefits of having tracing information. Now, generally speaking, when goods are being transported, they have to be able to be traced through a number that is associated with goods. There are two kinds of numbers that are used widely, and in supply chain management, one is called a global trade item number, GTIN. And this is a 14-digit number used to identify trade items, products, services. This is specifically, GTINs are used in the US. In other countries, there is a similar number that is used, but it's called ASIN. So these numbers are put on products and even services are identified through a GTIN or a ASIN, depending which country the origination is from. And this basically helps with tracing products, right? Okay. Now, there's another a number that is commonly used in supply chain management, which is the serial shipping container code, also known as SSCC, and this is an 18-digit number used to identify logistic units. And this is often encoded in barcodes or RFID tags. Okay, so up till now, I kind of gave you an idea of what tracing is, and, tracking is and tracing is and all of these good things. And so I hope before I move on, let me just clarify a couple of things. So again, tracking is, what's the difference, if I ever ask you what's the difference between tracking and tracing, you should immediately be able to think back to this particular slide, right? And so when there is all of these milestone reporting done, then basically this helps you track your goods, understand where they are in the journey, when they're going to reach the destination. And many times if you order food, let's say from Food Panda, you'll get this kind of a report. Okay, your order has been placed, it will be reaching you by X number of time. And as you refresh your screen, you'll be able to get a more updated version of that. So that's the tracking aspect. And here, then I also spoke to you about the tracing aspect, being able to trace back where goods originated from. And in order to be able to trace products, again, I'm repeating this, but there are certain numbers that are associated with products. And so, some of them are put within a barcode. Otherwise, maybe they're big boxes, but generally speaking, you'll see that products are associated with numbers, and those numbers are the numbers that help companies trace the product back, right? So the milestone reporting is basically done for tracking products, and these GTIN and SSCC numbers are basically used to trace products backwards to the source. All right, so we have so far understood what the new requirements in supply chain management were, and because of these tracking and tracing needs, as I mentioned a little while earlier, there has been a requirement for new technologies. And these new technologies have emerged, and they're basically three different categories of new supply chain technologies. And I'm going to be discussing each one of them with you. The first one is capturing and translating information. And the types of technology that is used to capture and translate information, the types of technology include barcodes, scanners, RFIDs, smartphones, and Internet of Things. And so you basically take physical products and you put a number on them, or you put an RFID code, RFID tag on them, and through that you have digitalized the product, and then later on you can easily be it will help you with the whole tracking and tracing aspect. So that's the first type of technology that has emerged. The second kind of technology is what used for transmission and upload. And so this is where you're moving digital data from a local source to global or cloud system and database. There is the types of technology that is used for transmission and upload is EDI, APIs, and GPS systems. And so basically, this happens when one machine talks to another machine, when goods are being transmitted or changed from one location to another. And being able to, you know, constantly understand where they are in the supply chain. Well, these are the types of technologies that help you do that. Finally, there is another kind of technology, which is the access and actionability. And so you have all of this information. This kind of technology helps you process that information and make decisions based on that information. And here, the types of technology are supply chain execution systems, transportation management systems, control towers, platforms, and blockchain. Okay. So and now I'm going to talk a little bit about the Internet of Things before I go into more detail about each one of these technologies. I think it's very important for us to really understand how machines talk to each other. And this entire idea of machines talking to each other is also called the Internet of Things. And this is causing a connected electronics explosion. It is huge. So what exactly do we mean by Internet of Things? It is the internetworking of physical devices, vehicles, buildings, and other materials. So what happens is that whether it's any machine or where any product is embedded with electronics, software, sensors, and these sensors allow information to be collected and exchanged. And so the tagging of things is achieved through barcodes, QR codes, and digital watermarking. And the aim is that all objects in the world, all objects, have an identification device or machine readable identifier that would transform daily life. So whether it's a pencil or a pen, if you pick up a pencil, a pen, anything, usually there will be some sort of an identifier on it. And even if you go to the smallest store nowadays, you'll see that they have, barcodes, and they're using these barcodes. It is expected that by 2025, 30 billion devices will be connected to the internet. And so this is the Internet of Things that has been evolving, and it's another game changer. All right, now let's talk a little bit about smart objects. Again, this is in continuation with what I was just mentioning. And a smart object is anything that is an object that enhances the interaction not only with people, but also with smart objects. And so this is anything with, let's say, an embedded chip in it. And this then becomes a smart object because you are able to basically store information in that chip or collect information from that chip about that particular product that has the chip on it. There are a lot of various interesting things that have been happening with regards to Internet of Things. There are certain sensors that can be put on goods that you buy, let's say in even a grocery store. In the future, you may be buying a milk carton, for example, that has a small chip on it. And so when the milk is, let's say, close to being finished, that chip will send a signal to the homeowner saying that, look, you may need to buy some more milk soon because you're running out of it. In the future, it's expected that there may be even computer chips being put under people's skin that provide real time vital signals to be able to trace those people. And I recall that I read something very recently that something like this has been happening in Sweden recently. In the future, there will be remote control apps. Some of these are already there, where if you leave a room, the lights switch off themselves. If you enter a room, the air conditioner may turn on itself, and so on and so forth. All of this is being made possible through smart objects. There's also this whole idea that, in vehicles, there are going to be sensors placed within them. And these basically make them, it's easier for to be able to track vehicles. And so in the future, it's expected that there will be a lot of smart cities, and you can, and the flow of traffic will be a lot better because there will be computer programs that will be able to trace and track what's going on with vehicles and maneuver traffic situations accordingly. It's expected that there will be sensors on infrastructure in the future, and this will be able to help, for example, if there's something that's about to break, or something that needs some sort of a maintenance, then it would, those kind of sensors would alert the main people involved to come in and make those kind of changes, whatever the required changes are. There will be, smart appliances that you'll be working with at home in the future, and this will hopefully make household chores a whole lot more efficient and easier to do. So again, I'm repeating in the slide that by 2025, nearly everything in daily life will have a connected application associated with it. So generally, it's not just enough to have a chip on something. You want to be able to have an associated software that is able to really communicate with that chip and give information, collect information, store information. And so, as mentioned over here, there will be a connected application with almost every single object. And we can think of each person as a plug and each part of life as a socket. So this just goes on a little bit more in details regarding Internet of Things. And this is a very interesting chart because over here you can see that by the trajectory of how the Internet of Things has been increasing. And so in 1992 there were just, I would say, a million goods with Internet of Things embedded in them, or the chips embedded in them, and then slowly and steadily by the year 2020, it's gone up to 50.1 billion products, and the expectation is that this will grow at the same rate exponentially. And again, because of the Internet of Things, everything is then gets connected, right? And then machines can work, speak to different machines, and humans can speak to machines, and machines can speak to humans. So it's really changed how things are operating. And so now we have this kind of a global nervous system that we're working with, where everything is effectively is connected. All right, so moving forward now, I am going to be talking. Okay, so next up now, I'm going to get a little bit more, talk to you a little bit more about this whole data capture and translation technology. And one of the main ways that data is captured and translated has been barcoding. And barcoding is something, let me just open the slide, that is basically, it's an optical machine readable representation of data, and describes something about the object that carries the barcode. So this is a typical barcode. And this barcode technology was first introduced in 1974. So it's been around for a while. It's quite, accessible now. Most people have it, even in smaller stores now they have it. And so every product gets this kind of number, and then it also, there is a barcode, and the idea is that this number that is then placed on product represents or describes something about the product. And this machine reader is able to, once it reads the barcode, it's able to understand something about the product. Okay. Now, there are some benefits of barcoding and there's some limitations or disadvantages of barcoding. So let's talk about both of these. In terms of the benefits of barcoding, it enables accurate and efficient data collection all along the supply chain, including the point of sale. So again, great for data collection. Okay, it easily tracks movement by SKU to identify fast snow movers, monitor promotions, and measure marketing impacts. So again, it's very good for tracking products along the, um, tracking products, let's say in a grocery store. Okay, where is it right now? Once you have the barcodes, that it should be easier for you to figure out where your goods are in your store. It enables profiling of individual consumers through voluntary discount or membership cards. So if you give discounts, right, and or you have a sale put up, now when you have these barcodes, you can see, okay, I put the sale, does that, and has it resulted in an increase in the number of goods that I've sold? So this, barcoding helps you see the benefits of having these kind of promotions. Also, if you have certain frequent customers, you can basically profile the customers through voluntary discount and membership cards. It's relatively low cost and extremely accurate as regards to, just entering data manually, or and so the other really good benefit about it is it really doesn't require much power. So it's not like, it's just a simple and easy kind of product. Once you have a barcode generator, it's just easy. It's not like you need a lot of electricity for it, and the maintenance cost is relatively low. The limitations is that the barcode can only read, the digitalized stickers up till 15 feet or 4.6 meters. Anything further away, it cannot read, and every item has to be individually scanned for it to be read. Barcodes can easily be counterfeited or replicated. Typically, only the type of item is contained, only one kind of item is contained on a barcode, not an individual unique code. Typically only the type of item is contained on a barcode, not the individual unique code. So for example, if there is, um, you know, a yogurt, right? So generally, it's just going to be the description would be flavored yogurt. It's not going to go into the details. The barcode, you can't really store the minute details. It's strawberry flavored, or vanilla flavored, yogurt. It just sort of captures the basic categories. It doesn't go into the individual uniqueness of each product. Also, these are read only, and information on barcodes cannot be updated or added. So this should give you generally a good idea of what are the benefits and the disadvantages of barcoding. All right, next up, I'm going to be talking to you a little bit about radio frequency identification. And this is also known as RFIDs. RFIDs is a system that uses electromagnetic fields to automatically identify and track tags attached to objects. The tags contain electronically stored information and can be passive, does not require power, or active, requires power. So, we have all seen RFIDs. Generally speaking, as mentioned in this definition, there are two kinds of RFIDs. One kind of RFID is a passive RFID, and this is basically more like a sticker. And this picture over here is an example of an RFID that's passive. It does not require any power. There are certain RFIDs that are attached to products that actually do require power. So here, for example, in this picture, there's somebody who's running, and this this RFID is going to be, trying to probably measure the speed and things like that. So, but here you can see a wire coming out of the RFID reader, right? So this requires some sort of power. So there are different kinds of RFIDs, and perhaps this gentleman over here has some sort of a chip embedded in maybe his watch or something, and when he passes by, the RFID will be able um, to collect in certain information and record that information. So it really depends. There are two kinds of RFIDs, but the whole idea is that this is different from barcoding, because here in RFIDs, there are electromagnetic fields that are basically being generated from RFIDs, and that is being used to track and trace products. So let's look a little bit now into the pros and cons of RFIDs. Okay, so if we start looking into this, the benefit is, one of the big benefits is that it can be read from a further distance. So barcodes, again, it was 15 feet, while RFIDs can read, the tags can be read up to 300 feet away, or 100 meters away. So that's a pretty powerful kind of an advantage there. The tags are highly durable, they're not easily damaged, and they are reusable. Multiple tags can be read simultaneously, so they're faster than barcodes. Tags can have read and write capabilities, so you can actually add information into the tags. That means that there are write capabilities, and so information can be updated or added to the tags as well. Tags can contain a lot of detailed information, including the lot size, the expiration date, maintenance information, etc. And another big advantage is that it's very difficult to replicate or counterfeit the data that because it can be password protected. Now, there are certain limitations or disadvantages of RFIDs. One of them is that they are a lot more expensive than barcodes. They also do not work well with metals or liquids, because metals and liquids interfere with the radio waves. And also it requires, there's an assembly requirement, and you have to insert the computerized chip, which takes a little bit of time, versus the barcode where they're just stickers and you just stick it on. RFIDs still have two separate chips. There are, so there are the read-only RFIDs, and then there are the readable, writable RFIDs. There are two types of RFIDs. And so they cannot be read by the same RFID reader or scanner. So usually if it's just a read-only RFID, you may have to have a separate RFID scanner. And for the readable, writable RFIDs, you may have to have yet a separate scanner. Okay, next up, I will be discussing the next type of supply chain technology that has been emerging. And this kind of technology is being used for data transmission and upload. And within this category, there is this technology that has emerged called electronic data interchange. And what this does is, this is a typical example of an Internet of Things where there is a computer to computer exchange of business documents in a standard electronic format between business partners. And this is just something pretty amazing, because it is, it's automatically generated. So you input certain information within a computer, and then let's say there's one manufacturer, well, their computer will then transform the information that you input in a certain exchangeable standard business document, and that will be sent directly to the computer in let's say your partner organization. And so this information is just sent computer to computer, and it's always done in a standard format. And this is something, EDIs have been around for the last 30 years. And this is a lot, and what the whole idea of this was that it replaces the manual process of sending documents via mail and fax and multiple data entry. So in previously, if you shipped something or you sent something, you may want to send a receipt by mail or fax it to the other company. Well, now you don't need to do that. Now you input the information, there's an EDI that's generated, and when the EDI reaches the other firm immediately, their computer is able to read the EDI that you generated, and they will know exactly when you sent the goods, um, by when they can expect to receive them, how much the goods were worth. All of that information is exchanged computer to computer. It doesn't have to be, there's no manual data entry. It's sort of automatically done. Um, there are different formats. There's different formats and different types of EDIs. There's the AN, SI, ACX, and EDIFACT, but I don't need you to get into all of that, those details. What I do need you to understand is that data is transmitted from one company to another through supply chain technology called EDI, which again is electronic data interchange. Now, this seems to be an amazing kind of a technology, and the reason is that it automates information exchange within partners in the supply chain. It simplifies information flows, where previously, there was a lot of human interaction and paper documents being exchanged. Now it's just, computer to computer information flows being exchanged. It's a lot easier. It eliminates sorting, distributing, organizing, and searching paper documents. It's more efficient storage and ease of manipulation of electronic records. You don't have to manually re-enter data. There's greater trading speed. Their cycle time is reduced. And there's overall a cost reduction of 20 to 35% within in companies when they use EDIs versus paper-based systems. There are certain limitations, though, to having EDI, and the limitations are that, sometimes it takes a little while. There's some latency, so information can be sent. There may be delays in sending information through EDI, because usually information is sent in batches. So it's not like all information is being sent in real time. So that causes, there may be some delays in sending of information. Sometimes, implementing EDIs, it can be a little bit difficult and time consuming, but once you get the systems in place, it works. It's a lot better than paper based. These can be expensive and so they can actually be having, incorporating EDI in your organization can be expensive. It's not very interactive. EDI only operates in one direction. So it's not that it's basically, it sends information. It does not receive information. So it's not an interactive software. Also, it's very rigid, and there is a certain way you have to have established certain, you have to follow certain processes and procedures to be able to use EDI. So it's not very flexible, and so those are some of the disadvantages. So let's talk about what are the alternatives. What are some of the other kinds of technology that is being used to, basically, send data and transmit for data transmission and upload technology. And the two other types of technology, in addition to EDI, that is used for this purpose includes application programming interfaces and real-time GPS, right? So again, real-time GPS, we kind of all know about this, because we have GPS systems in our, many of us use Google Maps when we need to go from one place to another, and that helps us, be able to not only know where the direction, but also many times you can, let's say you are going, I'm going from one destination to another. I can send the GPS of that to, let's say, my parents, and they can be able to track and trace exactly where I am. I believe it was Kareem. If you're in a Kareem, you can send your GPS to your parents, for example, and they can easily be able to trace and track exactly where you are and by when you're going to be reaching your destination. So that's an alternative way, again, machine to machine um, communication going on and it helps with the whole tracking and tracing. There's also API, which is just another form of EDI, except this form, the difference is that this is a web-based program. And so again, I do not need you to get into the nitty gritty details, but I do want you to just know that, you know, as far as in this particular category of data transmission and upload technology, uh, data is transmitted through EDI, API, and also GPS. Okay, finally, we've discussed, you know, two main buckets. We discussed the first bucket included, you know, barcodes and RFIDs. The next bucket included EDIs, APIs, and GPSs. And then this is the third bucket or the third category of technology, supply chain technology that has evolved. And this includes data access and actionability technology. And here, you know, you have a whole lot of data, right? You have a whole lot of data now that you've generated, but now you need to be able to make sense of this data and generate some valuable information out of it. And so basically, in order for to facilitate this, there are certain tools that are used. We've discussed, you know, ERP in our global supply chain management class. There's also transportation management systems, something else that we have discussed. But additionally, there are certain other things. There is something called supply chain event management systems. And these basically are, you know, they help you identify if a certain situation happens, then what you are supposed to do. So these are just systems that help you with decision making in supply chain management. There are also some technologies called supply chain control towers. And basically, these control towers, again, capture a lot of supply chain information. But the whole idea of having a control tower is that it gives you, helps you have end to end supply chain visibility. And so that's what the whole concept of control towers is. So again, these are just, again, high level. I would like you to just understand that in this third bucket, what are the kinds of technologies that have emerged? So all of this, again, all of these technologies incorporate IoT. You know, they can, especially RFIDs is an example of IoT. Being able, machine to machine kind of connectivity and communication. Again, you need, this is an example of an IoT, right? So net, I want to come back to IoT towards the end of this lecture and just talk to you a little bit about the advantages of IoT in supply chain management. So the advantages are that, number one, overall inventory management has improved. Thanks to all of this IoT and these chips and all this technology, there's a lot more real-time visibility and inventory, where it is in your warehouse, for example. You can track where it is there. You know, it eliminates a lot of the human error aspect, and so you can reach 100% inventory accuracy now through these new technology. There's also real-time supply chain management, and so basically what this means is that you will be able to manage your supply chain in real time, and if you're going to be running into any kind of issues, you can preempt them and make decisions that can, you know, reverse, or you can stop any problems from happening because you have access to a lot more information. There's a lot more logistics transparency. So especially at the point where, you know, things are being transported, now you can know not only where they are, but in what condition they are through RFIDs. And smart items raise alerts if the transportation conditions are not appropriate. And there's this is again something that is great because it stops, you know, things from getting destroyed while they're in transit. And this also helps reduce the cost of returns. It reduces, you know, defective goods, lowers the transportation due to you know, lower reshipping costs, and increases customer satisfaction. So again, if let's say you're transporting some food item, could be a big cake that's being shipped, you know, or shipped, or you know, taken from one location to another. If you put in a RFID chip, you could easily be able to monitor the temperature, what if it's in good shape, if everything is, you know, a-okay with the cake, and it's till the point it reaches its final destination. Similarly, if there's some medication that needs to be kept at a certain temperature in order for it to remain its you know, effective and contain its efficacy, then that you can easily track the temperature that it stays at throughout the journey. And if it's you know, if the temperature is going too high, you can have the ability to change the temperature as well. So all of this is net helping with, you know, logistic transparency and overall improving the customer satisfaction. And so the result of all of this is that time and money is being saved. Furthermore, there is improved warehousing, and there's you know, visibility is there's a lot more visibility in the warehousing. It's easy to locate products and understand where they are, place products in warehouses. And also there is an increase in the speed of delivery. Right? So things can, you know, it in general, thanks to all of this technology, things are moving quickly along the supply chain. I also, right at the end of this lecture, do, however, want to raise a couple of points. Number one is all of this technology is great. All of this is excellent. However, with all of this technology, there are certain vulnerabilities. 70% of Internet of Things devices, including sensors and connected infrastructures, have vulnerabilities that can be exploited. According to one study that HP did, each single device can be hacked in up to 25 different ways. And so that's something that's a little bit concerning. 80% of devices, including cloud and mobile apps, don't have very strong passwords. And so again, there's a lot of data privacy concerns that people have, because you know, there may be a smart television that they're have in their house, or certain information, and this can easily be extracted through hacking. And so a single, so and net, you know, in the future, people may even be able to have temperatures, a thermometer, a smart thermometer, smart locks as well. So just imagine if somebody hacks into those smart locks, an entire household or entire factory could be opened, and this can lead to some serious problems. So with that, I come to an end to this lecture. I hope you found this interesting. It's all related to technology of different sorts. And I will be giving you an assignment to follow up with this lecture. Thank you very much.